Welcome to another deep dive. Today, we're going deep into the world of the Paxos protocol.
Okay.
It's one of those things most people haven't heard of, but it powers a ton of what we do online.
Yeah, that's true.
But get this, its origin story goes all the way back to ancient Greece.
It really does. The Paxos protocol is this way for computers to agree on stuff even when things go wrong.
Yeah.
And yeah, the inspiration actually comes from the problems that lawmakers in ancient Greece had to deal with.
Wow, okay. Ancient Greece and like computer science, that's such a wild connection.
Yeah.
So how did those two things end up like connected?
Well, picture the island of Paxos, right? They had this parliament trying to make laws, but their communication wasn't exactly great.
Ah, yeah, back then.
Messengers could get lost at sea, storms could mess up their meetings, you get the idea.
Yeah.
It wasn't easy to get everyone on the same page. And Leslie Lamport, the guy who created the Paxos protocol, he saw this and realized it was just like trying to get computers to agree in a distributed system.
Huh. So he basically took this like age-old problem of human communication and applied it to the digital world.
Right.
Fascinating. Okay, but let's get into the specifics. What exactly does the Paxos protocol do, and why is it so important now?
Basically, it makes sure that a group of computers, even if some aren't reliable or the network is shaky,
Yeah.
they can all agree on a single value, and it has to be the correct one.
Okay.
Think about it like a network of computers managing a bank, right?
Okay.
You really wouldn't want one server saying you have like $1,000 in your account and then another one says you're overdrawn.
Yeah, that would be bad.
Paxos makes sure everyone agrees on the actual truth so you don't have those problems.
That makes a lot of sense. In a world where data is flying all over the place and constantly changing, you need a way to make sure everything stays consistent.
Exactly.
But how does Paxos actually do that? Like, what's going on under the hood?
Okay, so Paxos gives different computers in the system specific roles. You've got proposers, they suggest values, acceptors, they vote on those values,
Mm-hmm.
and learners, they figure out what the final decision is.
Gotcha.
It's a whole process, carefully designed, and it's got two main phases: prepare and accept.
Okay, let's break down those phases. What happens in the prepare phase?
So in the prepare phase, a proposer basically announces, hey, I'm about to propose something, and checks if anyone else is already working on a proposal that's higher priority.
Huh.
Kind of like politely checking in before you make a big decision,
Yeah.
just to make sure you're not stepping on anyone's toes.
So it's all about making sure everyone's on the same page and preventing conflicts before they start.
Yeah, exactly. And if nobody objects during that prepare phase, then the proposer moves on to the accept phase. That's where they formally propose their value to the acceptors.
And what makes the accept phase so important for actually reaching a consensus?
In the accept phase, the acceptors vote on the proposed value. If a majority of them say yes, then that value is chosen and the learners are told, this is it. This whole two-phase process with its careful checks and balances is what lets Paxos get everyone to agree, even if some computers fail or messages get lost along the way.
It sounds incredibly robust, like it can handle all the unpredictability of networks. But where do we actually see Paxos in action? Like, does it impact our everyday lives? It's kind of mind-blowing that something as complex as the Paxos protocol is just chugging along behind the scenes, keeping our digital world running.
Right.
Are there any, like, really obvious places where we see Paxos making a difference?
Oh, yeah, for sure. One big one is Google's Chubby Lock service.
Chubby lock service.
It's basically like a giant lock system for Google's whole infrastructure. Make sure different parts of their system can access and change data safely and consistently.
Yeah.
And you know what?
What?
Chubby uses Paxos to do it.
So every time I'm like searching on Google or writing an email in Gmail, Paxos is working in the background to prevent like data meltdowns.
Yep, exactly.
Yeah.
You could think of it as like a digital traffic cop, making sure the data flows in an orderly way.
I like that. And it's not just those apps, right?
No. Google's Spanner database, which handles massive amounts of data all over the world, that also uses Paxos for consistency and reliability. Imagine Spanner without Paxos.
Okay, yeah.
You try to update your Google profile picture, but without a consistent view of the data, you could end up with different pictures showing up on different Google services. Total mess.
Yikes. Paxos is definitely one of those unsung heroes of the internet. It seems like it's been around for a while. Have there been any big improvements or changes to it over the years?
Oh, yeah, definitely. Distributed systems are always evolving, so Paxos has seen some cool developments. One you might have heard of is multi-Paxos.
Multi-Paxos. Okay, so like Paxos, but more. Do we need to picture multiple ancient Greek islands now?
No. Multi-Paxos builds on Paxos, but adds this idea of a leader to speed things up.
Hmm.
Remember the prepare phase where proposers check for conflicts?
Yeah.
Well, with multi-Paxos, you usually elect a leader, and if that leader stays stable, you can skip the prepare phase a lot of the time, which makes things much faster.
So it's like choosing a spokesperson for the group. That way, not everyone has to weigh in on every single decision.
Yeah, exactly. Streamlines things quite a bit.
But doesn't having a single leader make it a single point of failure? Like, what if that leader crashes?
That's a good point. It's something multi-Paxos has to be careful about. Implementations usually have ways to elect a new leader if the current one goes down, so the system can keep working. It's a trade-off between speed and being able to handle failures.
Seems like there are always trade-offs to think about in these complex systems. You mentioned another variation, Raft, which I hear is becoming more popular. How does that stack up against Paxos?
Raft is interesting. It's not really an improvement on Paxos, but more like a different way of explaining the same core ideas. But it's designed to be much easier to understand and use.
So it's like taking a super complicated piece of music and arranging it for like a smaller band. The basic melody is the same, but it's easier for more people to play.
Yeah, that's a good analogy.
So Raft trades some of Paxos's complexity for being more user-friendly. Are there any downsides to that? Does it lose any of the guarantees that Paxos gives?
That's a great question. There's debate about that. Some people say that Paxos, because it's more formally defined, offers stronger guarantees. Others argue that Raft, when implemented correctly, is just as reliable and correct.
Sounds like there's no easy answer. It just depends on what you're building and what trade-offs you're willing to make.
Exactly. No silver bullet in distributed systems. Each approach has pros and cons, and the trick is knowing when to use which one.
Okay, time for a reality check. Let's talk about the problems and limits of these consensus protocols. Nothing's perfect, right?
You got it. Even brilliant systems like Paxos and Raft have challenges. One of the biggest with Paxos, at least in its pure form, is that it's super abstract, which makes it really hard to implement right.
So it's like having a detailed blueprint for a crazy complicated machine, but actually building that machine in real life is a whole different story.
Perfect analogy. Even super experienced engineers struggle to get Paxos right. And then there's the problem of live lock, which can happen in some situations, like when the network gets split.
Live lock, huh? Sounds ominous. What does that mean and what kind of trouble can it cause?
Imagine your network gets split in half, and each half has enough computers to form a majority. Paxos can get stuck in a loop where proposals keep getting made, but neither side can agree because they can't talk to each other.
It's like two groups of people trying to have a conversation, but they're both talking at the same time and nothing gets done.
That's it. Live lock is basically a communication breakdown at the system level, and it can bring things to a standstill.
Oof. In a world that depends so much on distributed systems, that could be a major problem.
Absolutely. Live lock could mean a website freezes or an app stops responding. Really emphasizes how important it is to design systems that can detect and deal with these situations.
It's like a never-ending battle against the unpredictability of networks and the challenges of getting everyone to agree in all this chaos. Are there any other challenges coming up that we should know about? What about things like quantum computing? How will that impact things?
That's where things get really interesting. Quantum computing, with its potential to break encryption, could be a whole new set of challenges for Paxos and other consensus protocols that rely on cryptography for security.
Quantum computing, always shaking things up, feels like every new technology brings new problems and new opportunities. Before we go too far down the quantum rabbit hole, let's recap what we've learned about Paxos. We've covered ancient Greece, the inner workings of Google, and even the dangers of live lock. And all of this is thanks to this protocol that most people don't even know exists.
It's a testament to people like Leslie Lamport, who can take inspiration from completely different fields and use it to solve complex problems that have a huge impact on our world.
And we haven't even touched on quantum computing. That'll have to be for another deep dive. But before we wrap things up, what's your final thought on Paxos? What's the one big takeaway you want our listeners to think about? What's the so what of all this?
I think the big takeaway is this. We live in a world that depends more and more on distributed systems, where data is constantly moving and changing across huge networks.
Right.
And without these reliable consensus protocols, things like Paxos, this interconnected world would be, well,
A mess.
yeah, way more prone to errors, inconsistencies, disruptions, all that.
It's like Paxos is the glue that holds our digital world together and makes sure things run smoothly even when stuff goes wrong, which it always does. We totally take it for granted. But without Paxos, being online would be like way less reliable and way more chaotic.
You got it. And what's even cooler is that the story of distributed consensus isn't over yet.
Oh, right.
Technologies like quantum computing, as they develop, they could introduce totally new challenges and new opportunities.
Okay.
Imagine a world with quantum networks that allow for even faster and more secure consensus algorithms. That could completely change how we think about distributed systems.
So even though Paxos has been this huge game changer, it's not the end of the road. There's still more to explore and discover.
For sure, that's what makes it so exciting. This search for dependable and efficient consensus, that's going to keep driving innovation as our digital world gets more and more complex and interconnected. It's a journey that's going to lead to new discoveries, new challenges, and a deeper understanding of how to build systems that can handle all the unpredictable stuff that comes with the digital world.
Yeah. It reminds us that we should never stop asking questions, never stop exploring, and always be ready to adapt as technology keeps changing.
And to our listeners, I'd say this. Keep learning. Keep asking those questions. Who knows? Maybe one of you will be the next Leslie Lamport, figuring out groundbreaking new ways to achieve consensus that will shape the future of our world.
That's a great thought. From those ancient Greek parliaments all the way to the future of quantum computing, our deep dive today has been all about the amazing power of human ingenuity. It's about solving tough problems and about how important it is to agree on things in a world that needs collaboration and understanding.
And remember, even if you don't become the next Leslie Lamport, even just understanding these basic concepts like Paxos, it helps you navigate our digital world in a smarter, more informed way.
Absolutely. Well said. Thanks for joining us on this deep dive into the incredible world of the Paxos Protocol. Keep exploring, keep learning, and until next time, stay curious.